and welcome back to TensorFlow. Today we are diving deep into one of the most crucial topics in data structures and algorithms, arrays. So arrays form the backbone of problem solving in coding interviews. Mastering them is essential for cracking top tech company interviews. So this is going to be the one-shot video on arrays. We'll be solving 6 must-known problems on LeetCode on this array topic, ranging from easy to hard. So we'll not only go through the solution, but we'll also discuss the optimal approaches and time complexities to help you ace your next coding interview. So now let's see that what are the problems that we are going to solve. So these are the 6 problems that we are going to solve. So although I have already uploaded individual videos on each of these problems, but if you want to learn them all in one go, from basics to advanced, this is the perfect video for you. So for programming, I'll be using Python for the solution, but you can follow along in any programming language. The algorithm remains the same, only the syntax changes. So to understand these problems clearly, I highly recommend you dry run every code, dry run every code that I show in these videos. So this will help you grasp the logic and optimize your problem solving skills. So the first step is to think that how you can solve the problem, and what could be the possible approach for solving the problem. After that, write the algorithm, write the basic structure of the code, and after that, write code, start coding. And then before submitting the code, dry run the code to understand it. So this will give you a solid understanding of every problem. So make sure stay till the end, take notes, don't forget to practice these problems yourself. If you will not practice, you will not get comfortable with these problems, and you will never be good in competitive programming and problem solving skills. So now let's get started with the video, guys. So let's first discuss that what are the problems that we are going to solve. So first we will solve two sum, then we will solve two sum 2, and then we will solve best time to buy and sell stocks, contain duplicate. So all these 4 problems are of easy range. Then we will solve one mid-range problem. So this is the mid-range problem, and then we will hop on to the hard range problem. So I will solve 4 easy problems, one medium problem, and one hard problem. So now let's get started with the video, guys, and solve all these problems and understand how to get the best approach for solving arrays problems on LeetCode. So the first problem is two sum, which is a very famous problem in LeetCode. So this is the problem, and we have to solve it. So first, we will read the problem very carefully, because sometimes we read the problem but we don't understand it correctly. So you have to read the problem very clearly so that you can understand the problem, and if you don't understand the problem, you will never be able to solve it. So let's read the problem. Given an array of integers nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So basically the question is saying we have an integer nums, and we have to find the two numbers which add up and get equal to this target. So, and then we have to return the index position of those numbers. uh, like in this case, 2 and 7 add up together to make 9. So we have to return the index position of 2 and 7. So the index position of 2 is 0, and the index position of 7 is 1. So now, as you can see in the example number second, 3, 2, 4, this is the integer array, and the target is 6. So if we will add 3 with 2, it will be equal to 5, and if we will add 2 with 4, then it will be equal to 6. So we will return the index position of 2 and 4. So now, for every problem, there can be many solutions in LeetCode. So like in this problem, you can also solve it using brute force. We can start two loops, and one by one we can check, like if in first loop we will take this as our number, and we will add this number with every other number in the array, so that we can find if this adds up to any number and return 9. Oh, sorry, add up to any number and its sum will equal to 9, so we will return the index position. So now let's write the brute force approach first. So for brute force approach, we will start two loops. One will acquire this element, the first element, and then second element, and then so on, and compare it with all other elements, add with all other elements and compare it with the target. So for this we will start first loop for I in range of length of nums minus 1, because we will iterate only to this target. Now for now we will start the second loop. We will use nested loop here. So for j in range of, now we want to compare this element with this and we want to compare the first element with the second to the last element in the array. So we will start this loop from I plus 1 till length of nums. Now we will cover if if nums of I plus nums of j is equal to target, then we will return the index position of these two numbers, which will be I comma j. And if we will not find any number, then we will return the empty array. Now let's run the code and see. Yeah, so as you can see, it is our code is working well, and it is solving every test case. Now this approach is the solution, but this is not the optimal solution, because in data structures we look for the optimal solution of the problem. So the time complexity of this loop will be equal to big O of n square, because we are using nested loops and we are using two loops here. So the time complexity of this problem will be n square. So now we will erase this solution and write another solution. So read the problem again. Now we want to compare the first element. We want to compare the first element with every other element in the array. But the optimal approach could be if we will store all these elements with their index number in the dictionary. So we can easily find that if the complement of this number exists in the array, so we will easily return the index position of that element. So let's create an empty dictionary here. So this dictionary will hold the numbers and their index values. Dictionary contain keys and values, so we will use keys as the element and values as the index numbers. So to do that, we will use a for loop for I in nums. For I in, we will use enumerate function here. So enumerate nums I comma j in enumerate nums. So this will give the index position, and this will give the number of actual element of the array. So now we will store d of j equal to I. So we are storing every element and their corresponding index in the dictionary. Now what we have to do is now we have to compare that if the first we will calculate the complement of this target, which means we will first calculate that what is the number comes when we will subtract 9 from the first element of the array, which means we will subtract target from the first element, and then we will find the complement. If that complement exists in the dictionary, we will return the index, which means first we will calculate 9 minus 2, which is 7, and then we will find 7 in the dictionary, and if we will find the 7 here, then we will return the index or the value of that key in the dictionary. So to do that, we will use another for loop for I in range of length of nums. Now first we will calculate the complement, which is c equal to target minus 9. Oh, sorry, target minus the first element of the array. This will give the value 7. For this example, this will give the value 7. Now we have to find if c in If C exists in D, then we have to return the index position. But there could be a case where C and the value of C and the first element will be same, because the complement value and this the first index will be same. So we have to handle that case also. So to do that, we will also check that and the position, the index number of that complement is not equal to the index number we are searching for, which means D of C is not equal to I. So now if this case is true, then we will return the index position of uh, the first element I and the index position of this element, which is D of C. And if we will not find any solution, then we will return the empty array. Now let's run the code. So as you can see, this is the optimal solution of the problem. And now we are getting 51% accuracy, and we are doing this problem in 3 milliseconds. Although this don't show the accuracy of the problem. If you will submit it again, it will change this percentage. Please try again, few seconds. Okay. So this is the optimal solution for the problem. In this problem, this problem is same as the first one, which is two sum. So now let's read the problem and see what we have to do in this problem. So given an one indexed array of integer numbers. So this means this line basically means that the in default arrays, the index starts with 0, like the first index is 0, 1, 2 and so on. But in this array, the indexing starts with 1, which means the first index is 1, second is 2 and so on. So this is the important point. So given in one indexed array of integers numbers that is already sorted, and the array is sorted in non-decreasing order, find two numbers such that they add up to specific target numbers. Let these two numbers be like this, returning the indices of two numbers and added by 1 as an integer. Okay, so this problem basically is same as the two sum problem, but in this problem we have two major changes. First is our array is one index, which means indexing starts with 1 2 instead of 0, and the array in this problem, the array is sorted in non-decreasing order. So these are the two important points that we have to keep in our mind before solving the problem. So the first approach could be of obviously the brute force approach, which is not so optimal. So we will not do that in this video. So now second approach could be as same as this two sum problem, in which we have created our dictionary, and then we have enumerated the array and stored all the values and indexed in key value pairs, and then we searched that our target is in the dictionary or not. So let's do this as same as the two sum problem. So we will create an empty dictionary first, and after that we will enumerate our array I comma j in enumerate numbers. Now we will store our store these key value pairs, and after that we will start another loop for I in range of length of numbers, and then we will first calculate the complement, which means we will calculate what will be equal to if we will subtract target from first number. So we will subtract target, the first element of the array, which means numbers of I, and then we will check if C in D and if C in D and C of D, I mean D of C is not equal to, if not is not equal to the index, same index which we are searching for. So then we will return our index which will be D of C plus 1. Why I'm doing this plus 1? Because the indexing of this array starts with 1, which means in default arrays it starts with 0. So obviously the whichever index we are getting here will be plus 1. So the second index will be I plus 1, and after that after that, if we will not find our elements which will be equal to target, then we will return the empty array. So now let's run this code and see if it is working or not. So it is showing some errors here. Output is 2 comma 1 and expected is 1 comma 2. So okay, so we have changed the indexing position here. So let's do this instead of DFC. So first we will return the index of I, first element, and then the index of second element. Now let's run this again. Okay, so our all the test cases are working. Now let's submit the code and see if it is working with every test case or not. So yeah, it is working with every test case, and it is giving 100% accuracy, which is not of our use. So now we have to find more optimal solution of this problem, because we have given that the array is sorted, and in this solution we haven't used the sorted array. So if we have given that the array is sorted, so we have to use that sorted array for our benefit. So now let's see how you can use that sorted array for your benefit and make this solution more optimal. So if you will think that let me give you an example. Copy this from here and paste it here. Okay, so if you will see here, this array is sorted. Now if if we will start if we will start two pointers, one from here and one from here, which means this will be our left pointer and this will be our right pointer. Now the target value which we are searching for is 9. Now if you will add this and this, what value will you get? So if we will add this and this, so we will get 17, which is greater than the target value. So now we will shift this element here. Now we will remove this element and we will search only in these three elements. So now we will move our right pointer here. So the next step is calculate the sum again. So we will add this with this. So by adding this with this, we will get 13, which is still greater than 9. So we will again shift this to right, and then we will add these two, and this will be equal to 9. So we will get our target value. My writing is very poor, sorry. So we will get the target value 9. Now if so, the approach is we have to take 2 pointers left and right, like in binary search, and then we will calculate if the sum of these two elements is greater than target. If the sum is greater than target, then we will shift right pointer to left, and if the sum is smaller than target, then we will shift our left pointer, and if it is equal, then we will return the values. So now let's do this here. So we have to start 2 pointers. So the left will be 0 and the right pointer will point at the last element of the array, which is length of numbers -1. Why -1? Because the indexing of this array is not the default indexing, it is a one indexed array. So we will -1 to get the last element position. Now we will start a loop in such a way. So what is the breaking condition of the loop? If left and right cross each other, then we will break the loop. It is same as binary search. So while left is smaller than right, if left is smaller than right, then we will compute this. We will calculate the sum every time. So let's calculate the sum. So the sum will be let's call it S. So the sum will be numbers of L plus numbers of R. So then we will compare if S is greater than smaller than the target value. If S is less than target value, then we will shift our left pointer to right side, which means we will shift our left pointer here. So left will be plus equal to 1, which means left will be +1, and if if, which means the next condition is if the sum is greater than target. If the sum is greater than target, then we will shift our right pointer to the left, which means uh, minus equal to 1. And else, if the sum is equal to target, then we will return left and right, which means the index position where we have found the element. Now let's run the code and check if it is working or not. So I think there is some problem in the code. The output is 0 comma 1 and the expected output is 1 comma 2. Okay, so we have to add plus 1 here because the indexing is one index. And now let's check the code again. Okay, so our all test cases are working, and now let's submit the code and see if it is working with every other test case or not. So yeah, it is working with every other test case, and we have found the optimal solution. We have seen three solutions of this problem. The first one was brute force, which is not so optimal, and the second one was as same as the two sum problem, and then the third one, which is this. So I did this solution because in this problem it is given that the array is sorted, and if in any problem if this is given that the array is sorted or in decreasing or increasing order, so you have to use that information for your benefit. So
We have already solved
that's
these
it
two
for today.
problems, which is two sum and two sum 2. So now let's take a look at this problem. So this is the problem called contain duplicate. So now let's read the problem statement. So the problem is given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So we have to check that if there is a duplicate number in the given array, and we have to return true if there is the duplicate element, and we have to return false if there is no duplicate element in the array. So to code this problem, first we have to think that what could be the possible approaches to solve this problem. So the one very easy approach that comes to my mind is we can easily sort this array and then check its neighboring element. If there is the all the duplicate elements will come next to each other, so we can easily find the duplicate element in the array. So let me give you the practical example of this. So this is our array. Let me zoom it. So this is our array, and now let's sort this array. The sorted array will be 1 comma 1 comma 2 comma 3, and this is our sorted array. So now okay, so now to do this, to find the duplicate element, we just have to see that if the this element is equal to the next element. So we just have to check the neighboring elements, and if the neighboring element is equal to the previous element of the array, then we have to return true. So otherwise we have to return false. So to code that, let's first write the code. So we just have to sort the array first. So in Python we can easily sort the array by writing nums dot sort, and this will sort our array. And after that we will start a loop. We will use for loop. So for I in range of, we will start the loop from first element and compare with every previous element. So from 1 to length of the array, and then we will compare if the first element, which means the nums of I, is equal to the previous element, which will be nums I minus 1. So we have to check if this element is equal to the previous element, then we will return true. Otherwise we have to return false. So here we will write return false. So this will give the clear understanding of the problem. First we are sorting the array, and then we are starting a for loop here from 1 to the last element of the array, and we are checking at every iteration. We are checking if the current element is equal to the previous element, and if it is the case, then we are returning true. Otherwise we are returning false. So now let's run and check if the code is running and passing the test cases or not. So it is giving some. Okay, so it is not it is nums. And yeah, so it is running, and let's submit this and see if it is running with every other test case or not, because sometimes when you submit it will give you an error. So yeah, this code is running and passing every test case. So now let's talk about another approach for solving this problem. So we can use one more approach for solving this problem, which is the set approach. So we have a special type of data, special data type in Python, which is called set, which only store one element only one time, which means the set do not store duplicate element. So we will use this data type for our benefit. Now let's clear this code and write another code for this. So for this approach, we will create an empty set. So this will give us this set. So we have created an empty set here. Now we will iterate over this array called nums. So for I in nums, we have to iterate over this array. For I nums, if I is in if I in s, then return true, then return true, and otherwise else we have to uh, add this element in the set. Add this element in the set, and if we will not find any element duplicate, so we will return true. Return false. So now let's run this code, and after that we will understand that why we have used set and how this is working. So, uh, this code is working, and now let's submit this. And now let's understand this, that why we have used set here. So if you will see the time complexity of searching in set, you will find that this takes only big of n. But if you will use list here, this will give you the time complexity of n square, which means if we will use set here, list here or array here, this will give you an error of time limit exceeded. So if you will use the empty list here, so and here you will use append function, and if you will use this code, then it will give you the time limit exceeded. List object is append. So as you can see, the code is working, but when you will submit this, it will give you the error of time limit exceeded, because the searching time in the list is more than to compare of set. So as you can see here, it is giving the error time limit exceeded, because the search time of list is more than that of set. So you have to also think and use different kind of uh, data structures here to see that what things are working and what things are not working. And by this practice, you will get the clear understanding that where to use which data structure and how to solve the problems more optimally, so this is the problem, and this is the solution. And so let me correct this code again, and use set again and submit this. So yeah, it is working. And so we have seen these two approaches for solving the content duplicate problem. And in next video, we will solve the best time to buy and sell stock problem of LeetCode. So this problem is best time to buy and sell stocks. So now let's read the problem and understand the problem statement. So this is problem number 121. So the problem is, you are given an array prices where price I is the price of given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in future to sell the stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, then return 0. So you have to read this problem very carefully, because it is little bit complex. So what this problem is stating is this array is given. So this array, what this array is representing, let me show you. So I've copied this array. So what this array is representing, these numbers are representing price. So these numbers are representing price, and the index value of these elements represent the days, which means on first day the stock price was 7, on second day it was 6, then 5, then 3, then 6, then 4. We have to find the best time to buy the stock, which means we have to buy the stock on minimum price, and we have to sell it on the best day, which means we have to sell it on the maximum profit, and on the maximum when the price of that stock is maximum. So to solve this, we have to think that what could be the possible approach for this problem. So
let me give you an hint. We have to find the day where the price is minimum. So the first thing we have to find is minimum price, and the second thing we have to find is maximum profit, which means we have to find the day where the price is maximum. So we have to find minimum price and maximum profit. Now the hint is, if we will take this minimum price as infinity, if we will initialize this minimum price with infinity, so every other price in the array will be less than this. And if we will initialize this maximum profit with 0, then every other profit will be greater than this value. So this is the hint, and this is the soul of this problem. So let me quickly erase all this. And yeah, so now let's dry run this problem and see what will be the solution of this problem. So as I told you, we have to start or initialize the minimum price with 0. So we have this minimum price, minimum price with infinity. So our minimum price is infinity now. Then we have to see if there is a price which is less than this minimum price. So we will iterate over this array and see if any price is less than this minimum price. So the first element is 7. Now obviously every element in this array is less than infinity. So the 7 is less than infinity. Then we will update this minimum price. So now the minimum price is 7 now. So then we have to calculate maximum profit. Then now we have to check again if another element is less than minimum price or not. Then there is 1. Then we have to check again if this is less than the current minimum price or not. So the current price is 1 and minimum price is 7. So 1 is less than 7. So now our minimum price is 1. So then we have to check again. Then the next element is 5. So the minimum price is 1 now and the current price is 5. So is 5 less than 1? No. So now our minimum price is 1 again, and we have one price more than minimum price, which is 5. Now we have to calculate our profit. So the profit will be 5, 5 minus 1. So sorry for my good handwriting. So the profit will be 4 here. And now let's check if this profit is more than our maximum profit or not. So we have initialized our maximum profit with 0. So we have initialized our maximum profit with 0 and minimum price with infinity. So the current minimum price is 1 and the current price is 5. So we have calculated the profit, which is 4. And now we have to compare, is this profit is more than the maximum profit or not. So 4 is more than, obviously more than 0. So now our new maximum profit is 4. Now let's run this loop again and see if this price is less than our minimum price or not. So 3 is less than 1, no. Then we have to calculate the profit again. So the profit will be 3 minus 1, which will be 2. And we have to check again if this profit is maximum or not. So to check that, we have to compare it with this. So 2 is less than 4 or not. So is 2 is greater than 4 or not. So 2 is smaller than 4, then the maximum profit is again 4. Now we have to check for this price. So this price is 6. So the minimum price, this cannot be minimum price because it is not less than 1. So the minimum price is 0. The minimum price is 1 again. And now we have to calculate the profit again. So the profit will be 6 minus 1. And the profit will be 5. So we have to check again if this profit is maximum or not. So to check that, we have to compare it with the current maximum profit, which is 4. And it is more than 4. So now the current maximum profit will be 4. You have to dry run this code with me, only then you will understand. So take a notebook and pen and try to dry run this problem with me. So now the current maximum profit is 5, and let's check with the last element of the array. So this is 4. We have to check it that is it a minimum price or not. So this is obviously not the minimum price because the minimum price is 1 and it is not less than 1. So we have to calculate the profit. So the profit will be 4 minus 1, which will be 3, and we have to compare it with 5. So it is not more than 5. So now the maximum profit is 5. Maximum profit is 5 and the minimum price is 1. So this will be our solution. Now let's code this algorithm and see if it is working or not. So the first thing that we have to do is we have to return the maximum profit. I think return the maximum profit. Yeah, we have to return this value. We have to return this 5 here. So now let's write the code for this problem. So the first step is to initialize maximum profit and minimum price. So the minimum price will be MP. The minimum price will be infinity.
So we have to initialize this minimum price with infinity, and then we have to initialize our maximum profit. So in starting, let's consider our maximum profit is 0. Now we have to iterate over this prices array. So to for iteration, we will use a loop for I in prices. For I in prices, then we have to check if this current price is less than our minimum price or not. So we have to check if the current price, which is I, is less than uh, our minimum price or not. So after that, if it is less than after that if it is less than the minimum price, then we have to update the minimum price, because we have found another minimum price. So we have to update the minimum price by I, which means we have found our new minimum price, which is 7. And then we will compare it again with when we will come here. So 1 will be minimum. Now we have found our minimum price. Now if this is not the minimum price, then we have to calculate the profit. So for profit, we have to um, subtract with the current price. So we will subtract the maximum minimum price with the current price. So we will subtract it with the minimum price. And if this profit is greater than the maximum profit that we have initialized with, then we have to update our maximum profit. So the maximum profit will be equal to the profit, which is this. And after that, we have to return the maximum profit in the end. So in the end, we have to return the maximum profit. Now let's dry run this code again and see how it will work. So in starting, we have initialized this minimum price with infinity. So the minimum price now is infinity and maximum profit is 0. So the first value in I will be 7. So we will check if this 7 is less than our minimum price or not. So our minimum price is infinity and 7 is obviously smaller than infinity. So we have to update this minimum price. So this minimum price will get updated, and here we will store 7. Now the minimum price is 7. Let me write it here. Now the minimum price is 7, and this loop will run again, and the I will contain this value 1. And then we will check again if this is less than our minimum price or not. So 1 is less than 7, so we have to update this minimum price again. So now our minimum price is 1. Then this loop will run again, and here I will contain 5, and it will check if 5 is less than 1 or not. So this 5 is not less than 1, so this price will not get updated. And then we will calculate our profit. So the profit will be I minus MP. I is 5 and minimum price is 1 here. So we will calculate the profit, and the profit will be, now the profit will be 5 minus 1, which is 4. Now our profit is 4, and after that we have to check if this profit is greater than the maximum profit or not. So now the maximum profit is 0, and we have to check if this profit, if 4 is greater than 0 or not. So 4 is greater than 0, so now our maximum profit is 4. Then this loop will run again, and I will contain 3, and this will check if 3 is less than 1 or not. So 3 is not less than 1. Then it will again calculate the profit and store it here. When the loop comes here in this value, then it will check if 6 is less than 1 or not. So 6 is not less than 1, so it will calculate the profit. So it will calculate the profit by my subtracting 1 from the current price. So the current price is 6 now, so 6 minus 1 is 5. So the current profit is 5. Now we have to calculate if now we have to check if the current profit is more than our previous profit or not. So our previous profit was 4 and the current profit is 5. So this will give us the idea that this profit is maximum, because the next value is 4, and the profit by this value will be 3. So 5 is greater than 3, so this loop will end and we will return the value 5 here. So now let's run this code and see if it is working or not. So yeah, this code is working, and now let's submit the code and check it with other test cases. So yeah, our code is working, and we have understood that what this code is representing, and how to solve this problem, and how to think clearly to solve this problem. So yeah, so this was the solution for best time to buy and sell stocks. So today we are going to solve another lead code problem, which is this three-sum problem. This is one of the most important problem in data structures and algorithm, and it is frequently asked in coding interviews at top tech companies like Google and Amazon. So before diving into this problem, I will highly recommend you watching my previous videos on 2 sum and 2 sum 2, because 3 sum is similar to these two problems. I would say it is the upgraded version of 2 sum and 2 sum 2. So now let's talk about the problem itself. So even though it is labeled as a medium, but some people find it quite difficult. So I don't know why they categorized it as medium. It should be hard here because this problem is quite difficult. So now let's read the problem and see what the problem statement is. So the problem is, given an integer array nums, return all the triplets such that I not equal to j, I not equal to k, and j not equal to k. And the sum of these three triplets, the sum of these three numbers should be 0. Notice that the solution set must not contain duplicate triplet. So the problem is saying we have given an integer array, so we have to find triplets in this array such that the sum of those triplets will be equal to 0, but we don't want any duplicate triplets in the solution. So now let's see what the problem is saying. I have copied this array from the problem. So we have given an integer array, and we have to find the pair of three numbers such that the sum of these three numbers will be equal to 0. But we don't want any duplicate triplet, which means if we found one triplet which is -1 1 0, this is the triplet whose sum is 0. So we can't use this again, which means if we find another triplet which is, let's say, -1 uh, 0 and 1 again. So although this and this have their sum equal to 0, but they are similar, which means 1 -1 and 1 1 and 1 0 is there in both the arrays. So we don't include these duplicate triplets in our answer. So now let's discuss the approaches we have to follow to solve this problem. So the first approach is obviously the brute force approach. We will see how we can solve this in most optimal way. But before solving it in most optimal way, let's try to solve it. Just solve it with using any method. So first we will use brute force approach. What brute force approach will do is it will take one number and try to find the combination of three. It is basically, it will find every triplet in this array, every triplet which is possible in this array, and then it will calculate their sum. If the sum is equal to 0, then it will store that triplet in our answer, otherwise it will ignore that. So for that we need triplets. So for brute force we will use three for loops. Sorry for the handwriting. So three for loops, we will use three for loops, and the first for loops will hold the first value, and the second for loop will hold the second value, and the third for loop will hold the third value. And we have one more condition here, that I should not be equal to j, I should not be equal to k, and j should not be equal to k. So what does that mean? It means if we are taking I as this, so we cannot take j as this, we have to take another number. So for that we will use some condition in our code. Now let's try to code this brute force approach in our LeetCode. So so let's start with the first for loop. So for I in range of, we will iterate over the nums array. So I in range of length of nums. So this is our first loop, and our second loop is for j in range of I plus 1 till the length of nums. Why we are writing I plus 1 here? Because we don't want I and j to overlap. That's why we are writing I plus 1 here, because from this number I will start, and from this number our j will start from the second element. So now let's write another for loop. So for k in range of j plus 1 till the length of nums. So why we are writing j plus 1 here? Because we don't want j to be equal to k. So that's why we are writing j plus 1, I plus 1, and this. So now we have to find if the sum of these three elements, which is nums of I plus nums of j plus nums of k, if the sum of these three elements is equal to 0, then we will store this solution in our so which data structure we can use for for ignoring duplicate values? So in our two sum problem, we have seen that we use set if we don't want any duplicate value in our answer. So we will use set here, because set, if you will, let me explain you. If you are passing 2 in the set,
and 2 is already in the set, then this 2 will be ignored by this set, and it will only hold 1 2 here, because set only store unique values, set only store unique values. That's why we are using a set here. And why we are storing only unique values, because we don't want any duplicate triplet in our solution, so we will use set as our answer. Now let's store these answers in our set. So set s dot add. Now we will add, we cannot directly add list in set, because list is not hashable. If you will try to store like this, if you will try to store it like this, nums of I comma nums of j comma nums of k, if you will try to store it like this, it will give you an error of list is not hashable. So we will not use list, so we have to typecast it into any other data structure which is hashable. So tuple is hashable, so that's why we will use tuple here. And we have to sort this, so let me explain why we have to sort it sort this before storing it to set. So if you will see here, let's take that example again. If one triplet is 1 0 and 1, and the another triplet is 0 minus 1 and 1, so these two triplets are same, but our these two triplets are same, but our set will not recognize it, because the elements are different in both the lists. So if we will sort this, so let's say the sorted array is minus 1 0 and 1. So this is the sorted solution. So if we will sort both of this will look like this. So our set will recognize that this solution is already in the set, so we don't have to store this again. So that's why we need to sort this solution. So for sorting, we will directly write sorted. So this will sort this triplet, and this tuple will typecast this list into tuples, and after that it will get stored in our answer, which is set. So now we have to return our triplet solution. So as you can see here, the output is in the form of list, but we have stored our solution in set, so we have to typecast it again into the list. So we will use list, and we will pass our set in this. So this line will typecast this set into list. So the return statement will return a list of triplets. Now let's run this code and see if it is working or not. I think there is some, okay, so this is not num, it is nums. So now let's run the code. So as you can see, we have passed every test case, but if you will try to submit this code, this will give you the time limit exceeded error, because it is using 3 for loops, and the time complexity of this code will be big O of n cube, because we are using 3 for loops, so the time complexity becomes big O of n cube. So we don't want that. So now we have to optimize this solution. And find more optimal solution. So now let's discuss another approach, that how we can solve this. So let me erase all of this. Okay, so now let's discuss the more optimal solution for this brute force approach. So let's read the problem again and understand that what this problem is stating. So we need to find 3 numbers, and the sum of those 3 numbers should be equal to 0. So let's say those 3 numbers are A, B, and C. So those 3 numbers are A, B, and C. So we want the sum of these numbers to be equal to 0. Now we are using three for loops in the brute force approach. We are using 3 for loops in brute force approach. Now let's try to optimize this solution first. We will find the most optimal solution in the end of the video, but let's try to optimize this brute force approach first. So we need 3 numbers, so that's why we are using 3 for loops. Now let's break this solution into parts. So we want the sum of A plus B plus C to be equal to 0. Now with first for loop we will find the A value, with second for loop we will find the B value, but we don't need third for loop actually, because we have A value and we have B value, and with these two values we can find C. Let's check how we can find C. So if we will see the formula, so it will become A plus B
minus a plus b. So this is the formula of finding c, because if you will send these two elements here, uh, that side of equal to, so this will become negative of a plus b. So for finding c, we don't need another for loop, so we can use two for loops, and we can directly find the third element without using any loop. So let me code this, and after that I will explain you that what this approach is. So let's erase this, try to write the optimal solution of brute force. So we will start an empty set for storing our answer. So this is the answer set. After that, we will start a for loop for I in range of length of nums. So this will be our first for loop. So by this we will find the first element of the triplet. Now we will store this in a. So we have found a, which is nums of I. Now we will use another set. First let me write the code, then I will explain it to you why we are using this set again. So then we will find our next element, which is j. For j in range of I plus 1, because we don't want to overlap I in j. So I in range of j in range of I plus 1 length of nums. Then we will calculate our now we have a and we have b, which is j. So now let's name it. Okay, so we have a, we have b, we have to find c. So the formula to find c is this. Now let's code this. So c will be equal to minus of a plus b, and what is b? B is nums of j. So now we found uh, c here without using any third for loop. So if c is in if c in s, if c is already in the set, then we will we know that we found our triplet. So we will again store this triplet in our answer. So a answer dot add tuple sorted, and here we will pass our solution list nums of I, nums of I, nums of j, and c. We have found our first triplet, which is nums of I, nums of j, a, b, and c element. And after that we will store or add this element s dot add nums of j in the solution, because because we want we will add this nums of j, so we can find this again in the solution. So nums dot add s dot add nums of j, and after that we will break the for loop and return our solution in the form of list. So list of answers. So now let's run this code and see if it is working or not. Okay, again I wrote num instead of nums. So yeah, we have passed again, we have passed all the test cases. Our answer is right. Now if you will again try to submit this code, you will get an time limit exceeded error, because we have optimized the brute force approach, but this is not the most optimal solution. The time complexity of this approach will be, because we have used two for loops, so the time complexity of this will be big O of n square. But what if I tell you that we can do this solution with the time complexity of big O of n? Now let's see how we can do it. So before that, let me explain you that how this code is working. So we have initialized an empty set, and after that we have started our first loop to find the first element of the triplet, and we have stored that first element in nums of I in a. So we have found our first element, and then we have initialized empty set again to store this j element, so we do not have to find this j element again and again using for loop. So we will store our element in this, and we will calculate c. Before for finding c, we will not use another for loop, we will directly find this c using the formula which we have calculated here. So we will find c directly with using a and b element, which is a and nums of j. So this is the formula of finding c, and then we will check if c is already in the set or not. If c is already in the set, which it means we have found our triplet. And why we are writing this code? Because we don't want any duplicate triplet, so that's why we are sorting this these numbers, and we are typecasting into tuple, because set cannot store list directly. And after that we will add this element nums of j in this set, because we if we will not add this element, this set will be empty forever, and we will not find the triplets. After that, we will return our answer in the form of list by typecasting this set into list. So this was the optimal solution of brute force approach. Now let's move towards the most optimal solution of this problem. So let me discuss the most optimal solution for finding the threesome problem. So for that, you should know that how to solve this problem, which is 2 sum 2. So I will again recommend you watch these two videos on my channel. I've already uploaded these two videos. So because this threesome problem is very similar to these 2 sum and 2 sum 2 problem. So now let's discuss the optimal approach for solving threesome problem. So now just think, if this array was sorted, if this array is sorted, let's sort this array. So the first element will be -4, and the second element will be -1, then again minus 1, -1, and 0 and 1 and 2. So this is the sorted array. This is the sorted array. Now if we first we will find the first element, which is I of triplet. First element is I. So let's say our first element is this. So this is the first element. Now we have to find two numbers of triplets, which is j and k, j and k, such that the sum of these three will be equal to 0. So now this array is sorted, and if you remember, in this question 2 sum 2, the array is sorted, and the problem statement of this question was we have to find two numbers such that the sum of those two numbers is equal to the target value we are searching for. So this is the same case. We have sorted array, we have sorted array, and we have one number, first number, which is -4, and we have to find two more numbers such that the sum will be equal to target, and our target is 0. So let me write here, the sum should be 0. So what we are finding here, we are finding two numbers such that the sum of these two numbers with I will be equal to 0, and the condition is the array is sorted. So what we did in this solution, in the solution of 2 sum 2, we have started two pointers, left and right. Now in 2 sum problem, we have started the left pointer from the first element and the right pointer from the last element. But in this 3 sum problem, we don't want any overlapping between I and j. So we will start our j pointer, which is a left pointer, from I plus 1, which is this element. So we will start our left pointer from this element, I plus 1, and our k pointer from the last element. So this is our k pointer. Let me erase this. So we'll start our right pointer from the last element, which is k. And now we have a element, b element, and c element, and we have to find if the sum is equal to 0 or not. So we will check I plus j plus k is equal to 0 or not, is equal to 0 or not. So if the sum is equal to 0, then we have found our triplet, and we will store this in a list. But if the sum is greater than 0, which means or smaller than 0, it can be greater than 0 or smaller than 0, because we will not get 0 always as a sum of these three numbers. So let's try with the first element. So let me write it here. So our first element is this, which is -4, and our j is pointing to this element, which is -1, and our k is pointing to this element, which is which is 2. So the sum of these three numbers will be -5 plus 2 equal to -3. So the sum of these three numbers is equal to -3. So this is smaller than 0. The sum is smaller than 0. In this case, the sum is smaller than 0 because the sum is -3. So in this condition, what we will do is we will move this j to the next position. We will move j one step further. Now the value of j is, so there is one more problem in the sorted array, is that we have neighboring element equal, which means if there are duplicate numbers, we have them in neighboring elements. So we have to deal with that problem also. Now let's first discuss the problem like this. After that, we will handle special cases. So now let's say our j is here now. So j is pointing to 0, and k is still pointing to k, and I is still -4. So now our I is -4, our j is 0, so plus 0, and our k is pointing to 2. So this is 2. Now the sum of this will be -2. So this is again still it is smaller than 0. So we will again move this j pointer here. Now our j is pointing to 1, so we will again calculate, and we will calculate till we find the sum equal to 0. And when we will find the sum equal to 0, we will store this answer in our list. Now let's code this and see how it will work, and then we will discuss the special cases and what are the anomalies in this problem. So let me copy it here, and let's start coding this. If you're not understanding this now, after I will write the code, I will dry run it, and then you will understand it clearly. So now let's write the code and understand that how this solution will work actually. So the first thing we have to do is sort the array. So we will sort the nums array. We will write nums dot sort. Now our array is sorted. Then we will again start an empty set. Although we don't need a set anymore because our solution is already sorted, but we will use set. So now the first thing we have to do is we will start with start our I with this element, and we will start two more pointers, j and k. Sorry, we have this sorted array. So we will start our I from this element, and our j from one I plus 1, and our k to the last element. So let's start initialize I. So for I in range of um, length of k, length of nums minus 1. Why we are writing this minus 1 here? Because we don't want I to be equal to k, which means if we will not write this here, the last element and the ith element will point to the same element, and we don't want that here. So we will write minus 1, and then we will start our j and k pointer, which is our left and right pointer, because array sorted. So j pointer will point to the first element, which is I plus 1, and k will point to the last element of the array, which is nums, which is length of nums minus 1. So this is pointing to the last element of the array, and this is pointing to the second element from I plus 1, second element of the array. Now the condition is we have to iterate over this array until j is smaller, till j is smaller than k, which means if j is equal to k, we don't want j to be equal to k here. So we will stop our loop here where j is smaller than k. If j is equal to or greater than k, this loop will end. So we will start another loop. So while j is less than k, we have to start this loop, and then what we will do is then we will calculate our sum. So the sum will be nums of I plus nums of j plus nums of k. And if, and we have to write if condition, if the sum is smaller than 0. If the sum is smaller than 0, then what we have to do is, if the sum is smaller than 0, then we will shift our k pointer to the right side. So we will shift our j pointer. Then we will shift our this j pointer. Let me choose another ring. Then we will shift our this j pointer to the right of the array. So we will write j plus equal to 1. And if the sum is greater than 0, then we will shift. If the sum is greater than 0, then we will shift our k pointer to the left side, which is minus equal to 1. If the sum is greater than 0, then we will shift our this k pointer to the left side of the array. And else, the last case is if the sum is equal to 0, then what we will do is, then we found our triplet. So we will store this triplet in our answer. So s dot add tuple nums of I, comma nums of j, comma nums of k, and we will increase the j and k pointer also. So now this is the solution, but in this solution we have two problems that we have to address. So let's see what are those problems. Let me copy this array and paste it here. So let me copy this array and move it here. So we have this sorted array. Now what we have to do is let's say our I is pointing to this element, and let's discuss the second iteration. Let's say our I is pointing to this position, and after that our I will, in second iteration, our I will come here. But this and these two elements are same. This is minus 1 and this is minus 1. In that case, our I is pointing two times on the same element, because this array is sorted. So we have every similar element in the neighboring point. So in this case, I is pointing to the same element. We have to deal with this case first. So to deal with this case, we will write here, before increasing or decreasing the I, we will write here if I is greater than 0. If I is greater than 0, it means if I is on the second or third element, if I is greater than 0, and nums of I, which is the first element, is equal to the previous element of the array. If these two elements are equal, in that case we don't have to do all this solution. In that case we don't have to do all this, so we will simply continue from there. So in that case we will continue and we will not calculate all this in that case. And the next case is, let's say, um, in next case, let's say our j is here, and in second iteration our j will move here. So our j will move here. So here first we have calculated it for -1, then we have to calculate it for -1, because in sorted array neighboring elements are equal, may be equal. So we don't want to calculate our sum for similar value of j, so we have to deal with this solution, this problem also. So for this we will easily write here that and in sorted array it can be like this. The first element is 1, the second element is also 1, the third element is also 1, fourth is also 1, and then we have fourth is also 1, and then we have 2, and so on. Then we have 2 and so on. So in first case, let's say our j is pointing here, then j is pointing here, and then j is pointing here. So these three elements are equal. We don't want, if we have calculated our sum for j equal to 1, we don't want to calculate it again for j equal to 1 and j equal to 1, no matter on which index j it is present. So in that case we will skip these two elements and we will move towards this unique element. So for that we will write while j is less than k and j is less than k, until j will reach the last element which is less than k. Here we want to check if the current element, which is nums of j, is equal to nums of previous element. And if it sorry, if we have to check this. Okay, so if until the j is less than k and the current element of j is the current value of j is equal to the previous value of j, then we have to skip j, which means we will plus equal to 1. We will increase the j until the value of j will be unique, which means this condition is false. Then we will iterate through this loop again. Until that, we will iterate in this loop and we will increase the value of j until we will find the unique value, like 0 or 1 or 2, until we will run this loop. Now we after this we have found our unique solution, unique triplets. So we will directly return this here. So we will return the list of our solution, which is s. So now let's run this code and see if this code is working or not. After that we will dry run this code and check the solution. So it is saying that int has no attribute to add. Okay, so we have initialized to a variable with same name, so let's call it answer, and we will add answer here, and we will return answer here. So we have initialized this variable and this variable with same name. That's why it has confused. So yeah, we have passed all the test cases, and now let's submit the code and see if it is working or not. So this time this will not show the time limit exceeded error because this is the most optimal solution of the problem. So as you can see, we have passed every test case. Now let's discuss that what we can change in this. So instead of set, we can use list here. Let me show you. We can directly use list here, L equal to, we will initialize empty list. And because we are dealing with duplicate element here, duplicate I here, and we are dealing with duplicate j here, so we don't need to store the unique solution, because we are making the solution unique by this and this. So we can directly append this solution in our uh, list. We don't need to typecast this. We can directly store this in list, and we can directly return the list. And if you run this code, this will not show you any error, because yeah, so every test case is running, because we don't need to store unique solution, because we are already handling every duplicate value of I here and every duplicate value of j here. So this is the solution, guys. And if you have not understand it yet, you please try to dry run this code, and after that you will see that how this code is working and how it is the optimal solution of the code. So the time complexity of this code is big O of n log n, because we are sorting the array here. So this will give you log n time complexity, and this is the most optimal solution for the three-set
How to
problem.
solve it?
So
So this is problem number 42, trapping rainwater. Trapping rainwater. This problem is tagged as hard. So now let's read the problem and easily understand that how to solve this problem. So the problem statement is, given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So we have given an integer array. Now what this integer array is representing? So let me open my notebook. So yeah, this is the integer array that we have given, and this is the graph or the bar chart of that array. So if you will see here, the first element of the array is 0. So what these elements are representing? So these elements are representing the height of blocks, which means the first block has height of 0 unit, and the second block, which is this, so this is representing the block of 1 unit. These are two blocks, so the height of these blocks is 2. The height of this block is 1, so here is 1. So now what we have to calculate, what
we have to find in this question. So we have to find that how much water can be trapped between these buildings or these blocks. So if you will see here, there is 1 unit water, 2 unit, 3 unit, 5 unit, 4 unit, 5 unit, and 6 unit. So total 6 unit water is trapped between these blocks, and we have to calculate the amount of water which is trapped between these buildings. So if you will see here, the answer is 6, because this is the amount of water that is trapped between these buildings. Now the question is how we can solve this question, how to measure the amount of water that can be trapped between these buildings. So before answering that question, I have another question, that what is the condition of water getting trapped between these buildings. So if you will see here, why water is trapped here, the answer is the water is trapped here because there is one higher building on the left side of this block and one higher building on the right side of this block, and the highest building is this. So the condition for water to get trapped between these buildings is there should be a higher building on the left side, and there is should be a higher building on the right side. We have to satisfy this condition for trapping the water. Now, how to calculate that, how much amount of water it will trap? So we will see that thing later, but first let's satisfy this condition of trapping the water. So what we will do is we will create two arrays, left and right. In left array we will store the higher building on the left side, and in right array we will store the higher buildings on the right side. So how to do this? Let's see how to fill this array. So we will start from the left side, which is this. So the first element is 0. So there is no higher building on the left side of this element, so we will store the current height of the building. So the current height of building is 0. Now let's go to the second element. The second element is 1, so the height of this building is 1. So is there any higher building on the left side of this element? No, there is no higher building than this element on the left side, so we will store the current height, which is 1. Now we will check for this building. So is there any higher building on the left side? Yes, there is one higher building on the left side, which is of height 1, so we will store 1 here. Why we are storing 1 here? Because there is one higher building on the left side of this element and the height of that building is 1, so we are storing 1 here. Now we will check for this. So if you will see here, there is no higher building on the left side which is higher than this building, this current building, so we will store the height of current building, which is 2. Now we will calculate same for this. So is there any higher building on the left side? Yes, of height 2. Then we will check for this. So is there any higher building on the left side? We have to check the highest building on the left side. So the highest building on the left side is this, which is 2, of height 2. So we will store 2 here. We will check for this. So is there any higher building on the left side? Yes, this is 2. Then we will check for this building. So is there any higher building on the left side which is higher than this building? No, there is no higher building on the left side which is of 3 height. So we will store 3 here. Now we will check for this. So is there any higher building? Yes, 3. So we will store 3 here. Then for this we will store 3. Then for this we will store 3 again, and for this we will store 3 again. So now we have filled our left array. Now let's fill the right array same as this. So what we have to fill in right array, we have to check that is there any higher building on the right side of every building or not, and we will start this from the right side. So we will store this element first. We will assume that this is the highest building on the right side, so this is of height 1. So is there higher building on the right side of this building? No, there is no higher building, so we will store current height of 1. Same for this. Is there any higher building on the right side of this? So no, there is no higher building on the right side of this, so we will store the height of current building, which is 2. We will check for this. So we have one higher building of 2 height, and then we will check for this. Is there any higher building on the right side? No, there is no higher building on the right side, so we will store 2 here. 2 here, the height of current building. Then we will check again for this building. Is there any higher building on the right side of this? So no, there is no higher building than this, so we will store 3 here. Then we will check for this. So there is again 3, so we will store 3 here. Then for this we will store 3. Then for this we will store 3. Then for this we will store 3, because there is no higher building on the right side of these elements which is higher than 3. And then for this we will store 3 again, and for this we will store 3 again, and for this we will store 3 again. Now we have satisfied the condition for storing the water, for trapping the water. Now we have to calculate, as a next step, we have to calculate that how much water is trapped between these buildings. So for that we have to check, if you will see here on this side. So if you will see here, sorry, here, if you will see here, 1 unit water is trapped. So the condition for the amount of water getting trapped is, if you will check this, if the water is like this here, if water is filled till here, so it will flow, it will from here. So the water can only be trapped till the height of minimum building, which means if you will take this and this building, let me erase this first and after that. So if you will check here, the amount of water which is trapped here is 1. uh, Let me take green pen. So the amount of water which is trapped here is 1. So 1 unit water is trapped here. So the amount of water that can be trapped between two blocks is of minimum height, which means if you will fill water till here, if you will fill water till the maximum height building, so this water will flow away. So the amount of water that can be filled between two blocks is equal to the height of the minimum height building on the left side, and it can only store water of minimum height building. So the condition is we have to check for the minimum height building, which means if you will see here, let me give you this example, this will clear all the concepts. So if you will see here, the amount of water which is trapped between this and this building is 1 unit. So if you will check on the left side, there is one building of 2 unit height, and on the right side, which is the higher building on the right side, this building is higher on the right side. So the height of this building is 3 unit. So it can only trap water which is equal to the height of minimum building. So this is the minimum building. Now here the water which is trapped is 1 unit. So we have to subtract this unit from here, the height of current building. If you are not understanding this, when I will write code, I will dry run the code, then you will understand that what I am saying. So try to understand this point first, because the amount of water that can be trapped between these two buildings is equal to the minimum amount height of the building, which is this, the minimum height 2, and the maximum height is this, which is 3 unit, and the minimum height is 2 unit. So the amount of water that can be trapped will be equal to this, but there is one more block under this water, so we have to subtract this block from this height, then only we can get the amount of water which is 1 unit. So we have to do this process for every block. We have to do this process for every block of this graph. Then we will find the amount of water that is trapped between these buildings. So let me dry run this code and show you how to solve this. So if you will check for the first building, so what is the minimum height of the building on the left side, which is 0, and what is the maximum height on the right side? Minimum height on the right side, sorry, what is the minimum height for first element? We are checking it for first element, that how much water the first element can store, which is this, it is storing 0 unit water. So we will check for this. So if you will take this element, the maximum height of the building is 0 on the left side, the maximum height on the right side is 3. So we have to take minimum of these two. Why minimum of these two? Because the water can be trapped, which the amount of water which will get trapped between two buildings is equal to the minimum height of the building. So we have to take the minimum height of the building. Now the minimum height is 0. So we have to take 0 and we will subtract from the current height, which is also 0. So the answer is 0 here. So on the first place, we have 0 unit of water. If you will check for this, let me copy this image, move this image from here to here, and let's check for this block. So let's check for this block. So for this block, this is 0th element, this is first element, and this is second element. So we have formula for finding the amount of water. So amount of water is equal to the minimum of left side of the building, highest building on the left side, and highest building on the right side, and we will subtract this from the current height of the building. So for the third element, we have height of 1 unit, highest is 1 unit. So minimum of 1 is minimum of 1, and on the right side what we have 0, 1, 2. So on the right side we have minimum height of 3. So we will store 3 here, and we are checking for this block. So we have left side we have one height building, which is 1 unit building, and on the right side what is the highest building, which is this building, which is of height 3. So we have 3 here. So the minimum of 1 and 3 is 1, and now we have to subtract the current height from the building. So what is the current height of the building? It is 0. So the amount of water which is trapped between these two buildings is 1. So as you can see here, this is 1. So this is the approach for solving this problem. Now let's write the code for this problem, and after that I will dry run the code and show you how this approach is working. So as our first step, what we have to do, if you will see here, we have to initialize two empty arrays, left and right, and the length of those arrays will be equal to the length of original array. So the first thing that we have to do is, step one is creating two empty arrays, left and right. So we have created two arrays, and the length of those arrays will be equal to the length of the input array. So we will store length of input array in this variable called n_higst. So the length of input array will be equal to, sorry, the length of left and right array will be equal to the length of input array. So we have created two empty arrays with the height with the length of n element. Now the second step is we have to fill our left array. So what we have to fill in this left array is we have to check for every element, for every input element, for this element we have to check that is there any higher building on the left side or not. If there is no higher building on the left side, then we will store the current height. So which means we have to start a loop for I in, so we will assume that the first element, the first building on the left side is highest building. So we will assume this. So the first element of this array will be equal to the HEIGST, height of 0, which means we are considering this element or this block as the highest block of all array. Now we have to start a loop for I in range of 1 to n. So we are starting loop from here. We are starting loop from here, and we have to store and we have to fill this array. Like we will check, we will take this element which is 0, and we will take this element which is 1, and we will check that what is the maximum between these two. So the maximum is 1, so we will store 1 here. Why? Because this will be the highest building. We will check maximum between both, and the maximum will be the higher building on the left side. So we will take maximum of L I minus 1 and height HEIGST, height of I, which means what we are checking here, we are comparing two corresponding elements. We are comparing these two. So we will take this and this element, these two elements, and we will check which is maximum between these. So 1 is maximum, so we will store 1 on the first element of the array. So we will fill like this, we will fill our left array. Now it's time to fill our right array. So we will start our right array from the right side of this diagram. We had started this array, which is this array. So we have started this array from the right side of the building. Let me use green pen. So we have started this right array from the right side of the graph. So what we have done is we have considered that the rightmost element of the array, which is this element 1, we have considered this element as the highest building on the right side. So we will do same here. So we will store n minus 1. On the n minus 1 place, we will store HEIGST, height n minus 1. So we are storing this element on the right side of the array. Last element of the right array, we have stored the last element of the height, which is 1. Now we will start another loop for I in range of n minus 2. Why I am writing n minus 2 here, I will explain it to you later. So minus 1, minus 1. So now I have started this from n minus 2. Why I have started this from n minus 2? Because we have already stored this element in our right array. We have already stored this element in our right array. Now we will start comparing this element with this element on the right side, and then we will compare these two elements on the right side, and then so on. So how we will do that? We will store in the right side. So for right side we will take maximum of right I plus 1 and height I, HEIGST I. So we are taking maximum of these two. First we will take this element and compare it with this element. Then we will compare this element with this element, and we will choose the maximum number between these two. So we are storing that maximum in our right element. So we have filled our right array and our left array. So in our left array, we have stored all the higher building on the left side. If you will see here, we have stored here in this array, left array, we have stored all the higher building on the left side of the array. And in this right array, we have stored all the higher building on the right side of the array, which was our condition for trapping the water. So now we have satisfied the condition for trapping the water. Now the next step is to calculate that how much water will be trapped between these two buildings. So for that, we have our formula, which is this. So for the formula is, we will take minimum height building between two blocks. We will take minimum height building and we will subtract it from the current height. Then we will get our the amount of water that is trapped between those two buildings. So for I in range of n, we will start this loop and we will iterate over this array, and for every element we will check a higher building on the left side and right side. So what we will do is we will let's initialize one answer. So let's assume that in first, when the iteration is started, the answer is 0. We will initialize our answer pointer, our answer variable from 0, and then we will add every time plus equal to, we will every time add the amount of water which is trapped between every building. So first we will check for this building. First we will check for this. So how we will check for this? We will take the first element of left array and the first element of the right array, and we will check that what is minimum between these two. So the minimum is 0 here, and then we will subtract it from the current height of the building, which is 0. Then we will get the amount of water trapped on the first block. So in this block, the amount of water which is trapped is 0. So by this we will find the amount of water. So minimum of left array and right array, minimum of left array and right array. After that we will subtract it from the current height of the building. So HEIGHT and current height of the building. And after that we will store every unit of water in this answer variable, and then we will return the answer variable. So let's check if the code is working or not, and it is passing every test case or not. So yeah, our code is working perfectly. Now let's submit it, and let me give you a quick overview of this solution. So uh, let me copy this image from here to here. So if you will see here, we copy this image. Okay, so let me copy new image from this. Sorry. So I have copied my left array and my right array. So let me give you a quick overview of this problem again, and I will explain it very clearly this time. So if you will see here what this left array is representing. This left array is representing that is there any higher building on the left side of every element or not, and this right array is representing is there higher building on the right side of every element of the array or not. So what this 0 is representing, that there is no higher building on the left side of this element, and the highest building is 0. And for this element we have the same condition. So for this element we have the condition which is we have highest building of 1 unit on the left side, and same for right, we have this condition that the most highest building on the right side is 3, and then we have 3 3 3, and if you will check for this element, the highest building on the right side is 1. So now we have our left array and our right array. We have satisfied this condition. This whole condition is for trapping the water. This is not for amount of water getting trapped. This is just for trapping the water. Now we have to calculate that how much amount of water will be trapped between these buildings. So for that condition we have to make a new formula. So if you will check for this building, I am giving the example of this building because this is the most common case of this problem. So if you will check here, what is the amount of water is stored on this place? So it is 1 unit. 1 unit water is trapped on this building. So how we will calculate this, that the amount of water is trapped between this building? So for this building we will check, is there any higher building on the left side? Yes, there is a higher building on the left side. Is there any higher building on the right side? Yes, there is a higher building on the right side. So what is the height of the higher building on the right side? It is 3. Higher building on the left side of 2 unit. Now we have to take minimum of these two. Why minimum of these two? So if you will see, imagine that this is the bucket and the one end of the bucket is longer than the other. So if you will store water till here, the water will not flow outside of the bucket, but if you will try to store water here, it will flow from here. So this is the common sense. We just have to take the height of minimum side. So the minimum side is 2 here. Now we have to subtract it from the current height, which means if you have this bucket and one side is higher, but till here the bucket is filled with the blocks, so the water will be only this is the amount of water that will be trapped. So we have to subtract it from this height. So now we are doing the same thing here. We are taking the minimum of 2 buildings and we are subtracting it from the current building. So we got our formula for amount of water, which is minimum of 2 buildings of left side and right side. We will take minimum of left and right for current building, and we will subtract it from the height of current building. That's the same thing that we are doing here. So now let me quickly summarize this code for you. So let me zoom in. So we are starting a empty variable in starting, we are assuming that the amount of water that is trapped between buildings is zero. We are assuming this case. Now we are taking the length of our integer array, and we are initializing two pointers, two arrays, left and right, same length of height. Why same length of height? Because we don't want to spend extra memory on creating a longer array. So we are taking this exact height of input array. So we are taking two empty array of n size. Then we are filling the first element of left array equal to the first element of input array. Why we are doing this? So let me give let me give you a visualization. So we are doing this because if you will see here, we are assuming that this is the highest building on the left side. The first building is the highest building on the left side. So we are assuming this here, and then we are starting a for loop, and then we are storing the higher building on the left side, which is maximum of previous building, which is 0, and the current height of the building, which is 1. So what is the maximum between these two? Which is 1. So we will store 1 on the first element. On 0th index we are storing 0, on the first index we are storing 1, and then this loop will continue and store all the maximum building of left side on in this array. Then we will start our right array. So in the end of right array, we are starting right array from the right side, from this side. So we start filling this array from the right side. So we will assume that the last input or the last element of this input array is highest building on the right side, because there is no higher building than this on the right side. So we are assuming this here, and we are storing the last element of input array in the last element of the right array, which is empty. Then we are starting a loop. We are starting loop from n minus 2 because we have to compare from this element. We are already assumed that this is the highest building, so we have to start from here. That's why we are starting from n minus 2 here. Then we will subtract every time. So we have to go here, 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 and here. So we will subtract minus 1 from every pointer, and this loop will run, and it will fill this right array. So we are storing maximum between the current height and the previous height. Now we will start another loop. This loop is for calculating the amount of water that will be trapped between two buildings. So for that, we have already calculated the formula, which is minimum of left and right, and we will subtract the current height of the building. So we are doing the same thing here. Answer equal to answer plus, every time we are adding this thing in the answer. So which is 0 plus the minimum height of left and right building. We are choosing the minimum height between left and right building, and we are subtracting it from the current height. After that, we will get our answer. Then we will return this answer, and we have passed every test case. So this was the problem, guys. Let me run this again. So yeah, this code is working perfectly. If you haven't understand it yet, try to dry run this code by yourself on the notebook, and try to visualize these two things. Take this graph as it is, take this graph and try to fill this left array by yourself, and this right array by yourself. After that, calculate this for 2 3 elements, and then you will get that what is the solution and how this approach is working. So
And
that's
it for the video, guys. We have covered some of the most important array based problems that frequently appear in coding interviews. If you found this video helpful, make sure to like and subscribe and hit the bell icon. Also, let me know in the comments which problem was your favorite, and if you have any other questions. So there might be some inconsistency in the video, because I have already uploaded some of these videos. So sorry for that, because I didn't get the time for editing. So I uploaded this video raw. So uh, keep practicing, keep coding, and I'll see you in the next one. Thanks for watching.